Hi everyone, I hope that you had an enjoyable chillax day, and you know that we have two lessons missed this week, so I thought it's important not to miss lesson time, and there's no other way that I can find extra time for you except as to explore cyber options. So what I'm going to do today is for this very short lesson, I'm going to focus on one very important idea. That is the idea of projectile motion being split into two independent motion, the horizontal and the vertical motion, and how that idea can be applied to actual problems. So let's revisit the important idea that we had last lesson. Remember the idea that I went through, the demonstration I went through with you, that I dropped something. It takes exactly the same time as something to go down to the floor. So because of that, we can actually split this motion into two independent motion. That is the y direction. This object B over here is exactly the same as an object dropped with initial velocity 0 and hitting the floor. But there is another motion, there's the x direction, where the object just moves at constant velocity. And why does it move at constant velocity? It's because this object does not experience any force. Of course, we are assuming that there's no air resistance. And that's important for you to understand why is it that there is no acceleration or no change in velocity in the x direction. That's for your syllabus. But of course, if you go to higher level, we'll do things that includes air resistance for the y direction. But of course, the more complicated situation is where you combine air resistance in both the x direction and y direction. That's way out of the syllabus. So we're going to focus on a situation where there's no air resistance in either direction. The acceleration is purely due to g, and there's no acceleration over here. Now we had one example that we went through for this. I'd like to just explore further examples where this idea about a projectile motion being able to be split into two independent motions further before we do questions on that involves numbers. So let's explore this example right now. What if you were to project something at an angle and the object goes like this? So how do we split this motion up into the vertical and the horizontal component? So if this is theta and is projected with speed u, remember that it is possible to break it down into the y direction and the x direction. So in the x direction is the easier one to begin with. The object can be seen as something moving at a constant velocity of u cos theta. Now why cos theta? Because if we were to break this velocity or resolve the velocity into the horizontal component and the vertical component, using simple trigo rules, this will be u cos theta, this will be u sin theta. Cool? So the vertical one is more important, the vertical component, because that's the one that determines the maximum height, the time of flight. So the vertical direction, this object would have exactly the same time of flight as something that is projected at u sin theta. Now where do I get the u sin theta from? It is from the vertical velocity over here. So, like what I said last time, if you want to determine the time of flight, it is usually the vertical direction that governs or that restricts the time of flight, because you stop flying when the object hits the floor, right? So it is usually the vertical direction that limits the time of flight. So let's go to one question that we had done previously for one simpler example, the previous simpler example. So let's say if we let this be 30 meters per second and this is 60 degrees and the height of the cliff is 50 meters. How do we find the time of flight? So this object over here, u sin theta, which is equals to uy, will be 30 sin 60. Alright? And we know if we take direction upwards to be positive, then we know that s, finally when it hits here, the displacement is downwards, so it is minus 50. The acceleration is pointing downwards, so it's minus 9.81, and I want to find t. I'm not interested in v, so the equation, as you have suspected, the equation to use is s equals to ut plus half at squared. So if we plug in all the numbers, minus 50 equals to u sin 30 sin 60 t minus 9.81 times half, over the half, and t squared. Now if I make this into the form of a quadratic equation, this is minus 4.905 plus 30 sin 60 t and plus 50 equals to 0. you can use the calculator. Let's try it now. I hope you know that this calculator over here has a mode which is to solve the quadratic equation. So minus 4.905, 30 times sine 60, and 50. And you're going to get two solutions. We'll talk about the meaning of the two solutions, but I'm going to take 6.8 seconds. The other solution would be minus 1.5 seconds. So to understand the meaning of these two solutions, we have to look at it from the quadratic equation point of view. So if you were to look at this equation, it's going to be like this. St, if you plot this out using a GC, it's going to look like this. And this is where your minus 50 is. So if you look at the quadratic equation, there are two solutions if we were to let s be equals to minus 50. There is this solution and this solution. And obviously, this is the one we want because this is even before the projectile was short. There's mathematical meaning, but there's no physics meaning. So this is the timing that we take. And because we understand that even though this solution has mathematical meaning, there's no physics meaning. And that answers another question that some students may have when you substitute minus 50 over here. Some students are worried whether it includes the time they're going to go up and come down. For some reason, some students are worried that if you substitute minus 50, you're finding the time from here to here. That's not true. Because if you look at the graph over here, if you substitute minus 50, you have taken into consideration the time to go up and come down. So if the point over here that I'm trying to make is that if you are very clear about your sign convention, the plus and minuses, and that's always why I always put this big positive or negative sign over here, refer to your sign convention and you will never go wrong. So be very careful of your sign convention. Now, since we are almost like through this example, might as well just find the range. So how do you find the range that it takes to that can fly? So remember, range has to do with the horizontal direction. So the time that it can fly forward before hitting the ground, multiplied by the horizontal velocity will be your range. So u cos theta times the time of flight. That will be 30 cos 60 times 6.8. And this is 30 times half 15, 15 times 0.8. That would be 68 plus 39. Yep, 68 plus 39, that will be 107 meters. Alright, so this is the range of the object. Now you can also go on to find the maximum height. So if you want to find the height over here, let's take a look how we can do it, shall we? So how do we find that height h over there? Now the height h over there can be found by taking this as the initial, this is the final. Now once we are clear about that, then the initial u will be 30 sine 60, the final is 0, the g is minus 9.81, and s is what we want to find. So the equation that doesn't have t is v squared equals to u squared plus 2as, and you find that s is equals to 30 times sine 60 squared divided by 2, 9.81. You're going to find it as 34.4. Now the question is this the answer for h? You have to be very mindful of this. What s are you exactly finding there? The question can be answered by knowing where is your initial and your final. So if this is the initial and this is final, the s that you're finding is this. So if you want to find h, you have to be very mindful that it's s plus 50, which is 84.4 meters. So what is the point I'm trying to make to bring across over here? The point I'm trying to bring across over here is that you have to be clear. What's the quantity you're finding? And the question can be answered, I should say that again, that the question can be answered by knowing exactly and being very clear about where is your initial, where is your final. Alright, so this is basically applying what we learned, the concept that we learned the last time, breaking the motion, projectile motion into horizontal and vertical component, and then treating any questions that deals with those two directions independently, breaking it down into a one-dimensional problem. So with this, I will leave it to you to take a look at the questions in the tutorial, and answers are provided, so give it a try before you come for lessons, and that will warm you up for the more difficult questions that I will have to go through with you in class so that I can give you more guidance. Alright, good day, bye-bye.